In this video, we are going to talk about remainder and factor theorem. So the first thing we need to review is how we divide polynomials. So in number 1, it gives me f and it gives me g, and they want us to divide f and g. So there are two ways we can divide polynomials. The first way is by long division. So let's review that. So if I'm doing 3x cubed minus 2x squared plus 2x minus 5, and I'm dividing that by x minus 2. The first thing I'm going to do is say, all right, I have x here. X times what is going to give me 3x cubed? Well, x times 3x squared is going to give me 3x cubed. So I'm going to do 3x squared times x to get me 3x cubed, and 3x squared times negative 2 to get me negative 6x squared. Now I'm going to subtract, meaning 3x cubed minus 3x cubed is going to give me 0. Negative 2 minus 6 would give me positive 4x squared. And then I'm going to bring down the next term. And then we're going to do the same thing. Now I'm going to say, okay, x times what would give me 4x squared? Well, 4x times x would give me 4x squared. I'm going to write that in blue. So I'm going to do 4x times x and 4x times negative 2. So 4x times x would give me 4x squared. 4x times negative 2 would give me negative 8x. So now I'm going to subtract 4x minus 4 minus 4 is 0. 2 minus a negative 8 would give me a positive 10x. Bring down the negative 5, and then we're going to do this one more time. So I need to say, okay, x times what would give me 10x? Well, x times 10 would give me 10x. So 10 times x and 10 times negative 2. So 10x minus 20. So I'm going to end up with a remainder of 15. So how we write our remainder is we write it as 15 over the divisor, so x minus 2. So that's long division. Now let's say we were going to use synthetic division. So what we're going to do is take the x-intercept of x minus 2, which means that x would equal 2. That's going to go on the outside. I'm going to do an upside down divisor, and I'm going to take the coefficients of my polynomial and put those in my box. So 3, negative 2, 2, negative 5. So the first thing I'm going to do is just bring down the 3. Then I do 2 times 3, and I put a 6 here. Now, in this one, instead of subtracting, we're always going to add down. So negative 2 plus 6 is 4. Then I'm going to do 2 times 4 to put 8 here. Adding down, I get 10. 2 times 10, I get 20 here. Add down, 15 is my remainder. So if I was going to write the polynomial, it'd be 3x squared plus 4x plus 10 plus 15 over the divisor, which is exactly what I got when I did long division on the other side. So we are going to be using a lot of synthetic division today, but I wanted to review how we do both. So part B says, let's evaluate f of 2. So if I evaluate f of 2, that means I would put 2 in every spot where there is an x. And when I do that, I get 15. Well, that's the same as the remainder. So what does this tell us? I don't know. Let's try again. If we have f of x equals this and g equals this, use synthetic division to divide f by g. So in this case, x would equal negative 1. So I'm going to have negative 1 on the outside. Now I'm going to have my coefficients on the inside. So I have 2, 1. Oh, I'm missing my x squared term, so I need to make sure I put a 0, then negative 3, then 6. Remember, if we're missing a term, so I'm going to have 2, 1, 0, negative 3, 6. So first, bring down the first number, 2. I do negative 1 times 2 to get negative 2. add down, I get negative 1. Negative 1 times negative 1 is 1, add down, I get 1. Negative 1 times 1 is negative 1, add down, I get negative 4. Negative 1 times negative 4 is positive 4, add down, I get 10. So this would be 2x to the third minus x squared plus x minus 4 plus 10 over the remainder, or over the divisor. So my remainder would be 10. So let's see if it works the same way if I just do f of negative 1. So 2, plug in negative 1 everywhere where I see an x. And I would get 2 minus 1 plus 3 plus 6, and that does give me 10. So what does this tell me? This tells me that if I divide a polynomial by a function, the remainder is the same as if I plug in the divisor into the equation. So C or opposite of C, depending on how you're looking at it. So let's try it here. Find the remainder if you divide this guy by this. Well, I'm going to do synthetic division. So negative 1. So really, I'm just plugging negative 1 everywhere where I see an x. And since I'm just plugging in 1, we can definitely do this without a calculator. Anything with an odd power is going to give me a negative. Anything with an even power is going to give me a positive. So this would give me negative 1. This would also give me negative 1, but a double negative gives me a positive. This is a positive exponent, so it's going to give me another positive 1 plus 27. So my answer is 28. So that would be the remainder for that division problem. In number 4, it says, if we have a polynomial that's divided by x minus 4, the degree of the quotient is 5, and the remainder is 2. What was the degree of the original polynomial? So since I was dividing by a degree of 1, my original polynomial would have had a degree of 6, since the answer was a degree of 5. And wants to know what is p of 4. Well, again, x equals 4 would have been what I was dividing by. So if I plugged in 4 and I got a remainder of 2, p of 4 would have been 2. All right, so now it's saying if they give us a polynomial x cubed plus kx plus 17, and the remainder when you divide it by x plus 1 is 26, what is the value of k? So this basically means when x is negative 1, we got 26. So that means I basically need to know if I plug in 26 for the f of x and I put in negative 1 for every x, I'm going to need to solve for k. So 26 would equal negative 1 minus 1k plus 17, 16 minus 1k, looks like it would do negative 1 plus 17. So if I minus 16 over, I would get 10 equals negative 1k, so k would equal negative 10. Show that x minus 1 is a factor of that polynomial. Justify your answer in 2 ways. So a factor would mean that we have a remainder of 0, because a factor means it would factor perfectly. So there are 2 ways we can show this. One, I can use the factor remainder theorem, meaning I can plug in negative 1, and I should show that my remainder would be 0. So let's do that first. So negative 1 to the 4th power would just be positive 1, so I'm going to get 3. Negative 1 to the 3rd power would be negative, so I'm going to have negative 7 plus 7 minus 3. Well, this will give us a remainder of 0. So that is one way that I can show. The other way is through synthetic division. So I put a negative 1 on the outside. I would put 3, 7. Again, I'm missing my x squared term, so I got to put a 0, negative 7, negative 3. So bring down the 3. Negative 1 times 3 is negative 3. Add down. Negative 1 times 4 is negative 4. Add down. Negative 1 times negative 4 is 4. Add down. Negative 1 times negative 3 is 3. Add down. So this would be my remainder. So since I have a remainder of 0, that shows that x plus 1 would be a clean factor of that polynomial. So what does this mean? Factor theorem. Let f be a polynomial. If, when you plug in the factor, you get 0, then x minus c is a factor of that function. If x minus c is a factor of the function, then when you plug it in, you would get 0. So graphically, what does this mean? That means if it equals 0, c is a real number, and c is an x-intercept. So going back to this example, if x minus 1 is a factor of this polynomial, that means if I graph that polynomial, one of my x-intercepts would be at -1. So we know that if we have a degree where it's greater than 1, you'll have at most that n x-intercepts. So let's try this with number 7. I'll leave kind of the theorem up there. Show that 1 is a 0, and then use this to help us factor p of x. So 1, let's do synthetic division. 1, I don't have the x squared terms of 0, -7, 6. So bring down the 1, 1, 1, add 1. And again, 1 times 1 is 1, so -7 plus 1 is -6. 1 times -6 is -6, so my remainder is 0. So essentially, when I divide, I'm left with this. That means my two factors are this times this. Oh, no, not plus. It'd be minus, sorry. So I need to figure out the other two x-intercepts by factoring this. Well, I need to find two numbers that multiply to -6 and add to 1. So that means this would factor into x plus 3x minus 2. So we already know that one of my x-intercepts is 1. That means the other one is -3, and the other one is +2. So if I was writing my equation in factored form, it would look like this. All right, our last question. Given the graph below, find the equation. You may leave your equation in factored form. All right, so I can see that I have a even function because both my arrows are pointing up with a positive leading coefficient. I can see that I have one x-intercept at -2, another one at 2, and then another one at 5 with even multiplicity. So at x minus 2, that means I'd have x plus 2, and it goes through at 2, so I'm going to leave it as a power of 1. Same with my x-intercept at +2. It's going to have a multiplicity of 1 because both of those go through at those values. At 5, it touches and goes back up, so that tells me it has a multiplicity that's even, so squared. And I said that this would probably be a degree of 4, so 2 plus 1 would give me a degree of 4. Now, we are going to have a leading coefficient, which we haven't talked about this yet. We're going to talk about this right now, is how do you figure out what the leading coefficient is? And this is going to be based on the y-intercept. So I see that my y-intercept is at -4, meaning 0, -4. So what I'm going to do is I'm going to plug in -4 for y. I'm going to leave my variable as a for that leading coefficient. And then I'm going to plug in 0 for all my x's. And I'm going to solve for a to figure out what my leading coefficient would be. So I'm going to have -4 equals a times 2 times -2 times, well, this is going to become 25. So -4 is going to equal, well, this is 2 times -2 is -4 times 25 is -100. So I have -100a. So that means my a value is going to be 1/25. So that's what would go in front here is 1/25 is going to be that coefficient for a.